Hello everyone, welcome to tutorial number 5 of the course Problem Solving Through Programming in C. So this is a SWAYAM course floated by Professor Anupam Basu from Department of CSE IIT Kharagpur, and I am Siddhant. I am one of the 3 TAs who will be in charge of the tutorial sessions for this course, where we will discuss the concepts that have been covered in the weekly lectures, as well as solve a few practice problems. Which will help you out with the assignments as well as the final exam. So this week, that is in week 6, the lectures were more or less concerned with arrays. So we will just have a very brief overlook of arrays and then try to solve a few questions on the topic. So let's start. So basically, what do we know about arrays is that arrays are a set of contiguous memory locations. What does that mean? Of a certain data type. So what does that mean? So whenever we define an array, say we define an array of some size n, or let size would not be the right terminology, of n elements. If I define an array of n elements, so what happens in the background is that in our RAM we get allocated a block of memory, a single block of memory, where, and say it is of n elements of integer type. So you will have a block of memory which can carry n number of integer values. So that would be the capacity of the array, that of the memory that would be allocated for that particular array, and you would get the memory of the address of the first element of the array. That is, when I define an array, so for example, let's consider one of this arrays. So I have an array which is basically this, that is 5 integer values, and I have defined it in some manner. So what happens is, in the memory, you have a very big memory which is your RAM, and in the RAM somewhere you get allocated 5 spaces which are equal to 5 integer spaces. So this is a singular block of memory, that is all the memory locations are contiguously placed, that is placed one after another, and you have a single block of memory of capacity of 5 int, right? That is, it can carry 5 int. Now when you define the array, you get the address of the first location, you get the address of this location of the first element, right? And using the address of the first element, you can actually traverse the entire array. You can find out, you can go through the entire array, you can try to find the elements of all the elements of the array, all the rest of the elements of the array, using the address of the first element and the size of the array. That's all you need. Okay, so that is a very brief overview about arrays. So why do I say it has to be of a certain data type? So that and what does that mean? So that means that whatever space is being allocated is to be equally divided into some number of elements that you provide, and that can be done only when you are dealing with the same data type. So if you are saying that I need a floating point array of floating point precision of n elements, so it will accordingly allocate space to you depending on how much the floating point, a single floating point data takes up memory. Similarly, if you define an array of integer elements, then it will allocate you the space which is equivalent to n integer values. Okay, so whatever space is allocated, it's to be equally distributed among all the elements of the array. Alright, so now that we know that, let's look at the first question, which is very straightforward in nature. So now, what is the right way to initialize an array in C? So you can answer in the chat box or unmute and answer. So here we have
option B.
Right. So what we are trying to do here is we are trying to initialize the array, that is we are defining the array as well as giving all the values to it. So the right way to initialize an array among this 4 would be this option B. So, or we can also initialize an array in this fashion. We could have just left it blank and we could have written this. In that case as well, it would have considered an array of which would have 5 elements, right? So we could have written this as well, but among all the other options that have been mentioned here, option A, C and D, they are incorrect. The option B is the only correct way to initialize an array among these 4 options. Alternatively, you could also initialize it in this manner with an empty square braces here. Because you are initializing the array, you don't need to give the number of elements. It will automatically take whatever number of elements you initialize. It will take that number of elements to be the size of the capacity of the array. Okay, so I think most of you answered that correctly. So we'll be moving on to the next question, which is say there is an integer array, and considering that integer takes up 2 bytes of memory. So we are defining an integer array of size 15, and the memory location of the first byte is 2000. So this has to do with the contiguous nature of the memory allocation that occurs here. So contiguous meaning that all the memory locations are allocated one after the other. So in that case, just think about this. So we have an array of size 15. So we start at 2000. So this is the first element space, first space for the element. So the second element space starts at 2002, because each integer, so it's an integer array and each integer takes up 2 bytes of memory. So if we start from 2000, so 2002 would be the starting memory location for the second element, and similarly 2004 would be for the third element, and 2006 would be for the fourth element, and so on, right? So now what would be the location of the 13th element of the array? So as you can see, every memory location, so every integer takes up 2 bytes, and we are talking about the 13th element of the array. So simply what we can do is we can do 2000 plus 2, which is the number of bytes that an integer takes, into 13, that is the 13th element. So if you do this, you would have 2026. So that would be the address of the 13th element of the array.
Option C.
Yeah, option C. So I hope that is clear to everyone.
Yes, sir.
Okay. Alright, so if you have any questions, you can ask them. Okay. So let's move on to the next question. So this is about the array initialization as well as.
Can you please go to the previous question?
Okay. Yes.
How the answer will be 2026?
Okay. So for the first element, the memory location starts from the memory location of the first element is 2000. All right. The memory location of the second element is 2002. The memory location of the third element is 2004, and so on. So you can see that every integer takes up 2 bytes of memory, and the starting byte of the array is 2000. So we are starting from 2000. So the first element starts from 2000. So if the first, and we know that the array is a contiguous group of memory locations, that means all the memory locations for all the elements are placed one after the another. So if we start from 2000 for the first element, our second element will start from 2002, third element from 2004, and so on. So in that case, the 13th element will start from 2000 plus 2 into 13, right? You can just does that make sense to you?
Yes, sir.
Okay, so that is why we get 2026 here. So the 13th element will start from 2026, the 14th element from 2028, and the 15th element from 2030. So that will be
Yes, sir. Yeah.
the entire array. Okay, so the first question in this page, the left side question, is related to the initialization of arrays. So can you just try to answer this?
This is 0, option B.
Okay, so whenever
Sir, a garbage value.
okay, so this is actually for the older compilers. If you would have older compilers, or you are using Turbo C, or if you are using older compilers like Turbo C, then you will get a garbage value here. Okay, because in older compilers you would have like, if you don't specify the value, unless you are setting some value to the element of the array, it is by default it is set to some garbage value. But in the more recent compilers, or most of the compilers that we use these days, you will get a value of 0 here. So for the int, especially for any integer array, when you are defining the array, it is automatically set, all the elements of the array will be set to 0 unless specified otherwise. That is, here you are initializing, so you are saying that this is an array of 10 elements, right? It has 10 elements and you are specifying only 5 elements, right? So the rest 5 elements of the array will be set automatically to 0. That is in the recent compilers. But if it was older compilers, then they would be set to garbage value, not 0. But keeping in mind that we are using the current compilers, I will say the answer is B here, which is 0. Okay. So if there is no doubt in this question, we can move on to the next one, which is related to undefined behavior that probably can be seen in an array. So
Option D, sir. Compilation error.
okay.
No output.
Okay, so it will be no output, but like it will compile properly. That's what you're saying. So what are we doing here? We are saying that we are defining an array of 2 elements, right? And we are initializing 5 elements, right? So what happens in that case? Like when the compiler sees that you are defining an array of 2 elements, it gives you a space which is which basically corresponds to twice the size of an integer. It gives you that much space, it allocates you that much space. But then it sees that you are trying to initialize 5 elements into an array which has the capacity to carry only 2 integers. So in that case, what happens to the other values that you give? So there can be 2 things that can happen. If the space is empty, if the space following that array, that wherever the array has been allocated, if the space following that array is empty, it might set the values there, or if it is not empty, you will encounter kind of a segmentation fault. That means you are trying to allocate some memory, you are trying to access some memory that is not allocated to your program, so you will get some kind of a segmentation fault there. But what happens in most of the cases is that you will get a compilation error here, that is a error during compilation, because you are trying to access, or you are trying to set more, you are trying to initialize more number of integers to a space which can hold only 2 integers. So here the correct answer is compilation error. Is that clear?
Sir, I have a question.
Yeah.
Sir, what is the sir unsafe code in array?
What?
Sir, unsafe code.
Unsafe code. Okay, unsafe code is a warning actually. It you can get that when you are trying to use, or you are trying to do something which might like it might occur or might not occur. For example, in this case, your compiler allocates you a memory space of 2 integers, and you try to cramp in like 5 integers to that memory space, but it cannot hold 5 integers, right? So then what it does is it checks if there are 3 more integer spaces available just after this array which has been already allocated of capacity 2 integers. So it checks if there is 3 integer space available there. If it is available there, it will allocate and it will probably save it. But if it's not available, then it will throw you a fault. And now what happens, and that is what it means by unsafe behavior. That means you don't really know when it might go wrong. Sometime it might work, sometime it might not work, but you ideally it will give you a warning that this is an unsafe behavior, and you shouldn't try to do this. You should, if you have an array of 5 integers, define if you want to save 5 integers in an array, then define an array which is of suitable size. So basically that is what. Okay. So if there are any further questions on this.
No, sir.
All right. Okay, so let's move on to the next question. So this is not an array question, it's a question for the loops and the switch case that we learned in the previous lectures, in the previous week's lectures. So try to solve this. Okay, so what happens in the first iteration? In the first iteration, I is equal to 0 before the first iteration. So as soon as the first iteration starts, I will become 1, because I plus plus, that is the first statement of the while loop. Then you have a switch case here where you are putting this character data, which basically comprises of the small letter a, and you have a matching case as well, where you are printing, and you are inside the case statement you are printing this character a. So you have a printed once, then break. So the switch case breaks, okay, and you come out of this loop. Then you go to the second iteration. Why do you go to the second iteration? Because the value of I is still less than 5, the value of I is 1, which is less than 5. So you go to the second iteration. So what happens in the second iteration? The I value becomes 2, and again you go into the switch case and another a gets printed. Then what happens in the third iteration? The I value becomes 3, and you go into the switch case and another A is printed. Then in the fourth iteration, I becomes 4, another A is printed. In the fifth iteration, so why we go to the fifth iteration is because I is still less than 5, so we go to the fifth iteration. Now I becomes 5 and another A is printed here, and then we go to the sixth iteration. Will we? No, we don't go to the sixth iteration because I has become 5, so I less than 5 is no more satisfied, and because this becomes false, it will bring you out of the while loop. Okay, and after that we are printing A again, and next line. So totally we have, this code will give you 6 A's as the output.
So zero is also include.
What do you mean 0 is also included?
अब मेरे कहने का मतलब है कि जीरो से हम स्टार्ट करेंगे तो हमारा 0 1 2 3 4 5 अगर हम इन एलिमेंट्स को गिनते हैं तो सर हमारा आंसर 6 आएगा, वो 5 जो है वो 6 बार प्रिंट होगा।
नहीं, ऐसा नहीं है ना, क्योंकि पहले यहाँ पे हम लोगों का आई प्लस प्लस स्टार्टिंग में ही हो जा रहा है, तो बेसिकली हम लोग 1 से स्टार्ट कर रहे हैं, ऐसे सोच लो। क्योंकि यूजुअली वाइल लूप हम लोग जब लिखते हैं या फिर एक फॉर लूप लिखते हैं, ये जो इंक्रीमेंट होता है वो सबसे एंड में होता है, और बेसिकली यहाँ पे आप अगर आइट्रेशन लिखते हो तो आपको क्या पता चलता है कि ये 5 जब हो जाएगा, लेस देन 5 है ना यहाँ पे, आपका मतलब लेस देन 5 है मतलब क्या, जब तक 4 तक प्रिंट होगा, 4 से ज़्यादा हो जाएगा प्रिंट नहीं होगा। तो आपका बेसिकली लूप्स हो रहा है, एक बार आई 1 हो जाएगा, 2 हो जाएगा, 3 हो जाएगा, 4 हो जाएगा, फिर 5 हो जाएगा तो ब्रेक हो जाएगा, तो टोटल 5 बार प्रिंट हो रहा है वहाँ से, है ना। फिर वहाँ से 5 बार प्रिंट हो रहा है, और एक बार हम लोग अलग से प्रिंट एफ करके एक ए प्रिंट कर रहे हैं, तो टोटल 6 हुआ ना, आप समझे?
यस सर।
Okay. So anyone else has any doubts in this question? All right. Okay. Okay, so let's go to the next question. So basically the question is like, which is the correct statement? Let's try to answer this. I think this should be fairly straightforward.
Option B.
B as in Bombay, B. Okay.
Yes, sir.
Okay.
Option A, sir.
Can store any data type as the data type of the highest precision. So let me tell you, the answer here is option D. So a array cannot be defined of the void data type in C. It has to be of a data type which is integer, floating point, character, boolean. It has to be some particular kind of variable. Like, it cannot be a void variable. Void means nothing, right? Like we usually don't use void mostly in C, but yes, once we go to functions, you will notice that we do use void sometimes. But void basically is a data type. That means it's not really, it's nothing. It's not really any data type. There is no data. That's basically what it means. And that also means that we cannot define an array which basically does not belong to any data type. It is there is no data in it, so we cannot define an array like that of void type. We can define an array which is of integer type, we can define an array which is of floating point type, we can define an array which is of character type, and so on. But it's not possible for us to define an array of void type. Yes, do you have any questions?
Sir, what if we use of a float variable?
Sorry, I couldn't. I couldn't get your question.
What is the void in front of a variable declaration while we declare int a
Hmm.
semicolon? That what if we mention void a? What does it mean?
That is what it's not really allowed in C. Like any variable can also not be of a void type. Like void type means you are trying to define a variable which cannot carry any data. That is what basically it means. It's void is actually better understood when you go into functions, as that the function does not return anything. When you want to say that the function don't return anything, then you say that the function returns a void type. That means it's nothing. It there is no data to return. So
Yes, got it.
so basically when you say that void of say a, which is a variable, it doesn't mean anything, because a cannot be a placeholder. Basically any variable is a placeholder for some data in the memory, right? Some memory location. And basically void means no data. So that is where the contradiction comes. Okay, the question is, in int main can we use variable having data type of float or char? In int main, so instead of int main you want to have float main or char main? Yes, it is possible. So basically the what do you say, like it's recommended to use anything apart from a void main in C. But I think void main, if even if you use void main with the recent compilers, it won't give an error. But yes, you can use int main, float main, char main, anything. Accordingly, instead of return 0, you can return 0.0, return some the small letter a, small letter b. It depends on you. So you can write uh, instead of int main, you can use float main or char main. That is fine.
Sir, main is a user-defined function or predefined function?
uh, it's a predefined function in the way that the execution of the code starts from the main. So every C code has to have a main, like for it to be like if it is executable, if you are supposed to run the code, if it is a source file for some computation, it needs to have a main, because that is where the computation will start from. So if you see it like that, then it's a predefined function. Like that is something that needs to be there in the code if you want to run that code. Is that fine for you?
Yes, sir.
But there can be, you can write a C program without a main, but that goes into a bit more detail, where you are not actually running that program there. For example, let me give an example. So uh, say this header files, what about a header file? What if you want to define your custom header file? Say I want to write a header file where I define some functions and stuff. So I write the header file, and I and then I write the functions within it, and that's it. I don't write a main there. Like there is no main function that I write in inside a custom header file. Then what I do is I import that header file, so those functions are included into my source code where I am trying to actually do some computations. When I import that custom header file of mine, then those functions that I have written inside that header file will just get they will be imported into my source code. But in that header file I have not really used a main. So in that sense, you don't uh, unless you are actually you want to run that code, or you want that code to be executable, only then you need a main function. Okay, else if you want to import that function somewhere else, import that file somewhere else, it's especially when you write very in the corporate codes, or whenever you write very large huge amounts of code, for example um, this operating system codes and so on, you tend to have a lot of small files which have predefined functions which does something, and you import all those files into the program which actually does some computations. So in those cases, those auxiliary files which do not actually run by themselves, they don't need to have a main function. But this program or this file which needs to be executed um, or needs to become an executable in order to get some computations done, this needs to have a main function. Okay, is that clear, or did I just confuse you even more?
Sir, where is the predefined function call
The
in header files or OS calling? Sir, who's calling?
okay, so basically I give you the example of the header files, right? So in header files you have, say, stdio.h. You have a lot of input output operations or functions already defined there. They are predefined functions, and stdio.h does not have a main function, because you don't need stdio.h to be computed or to be compiled, and I mean it needs to be compiled, but it does not need to be executed. Okay, so by itself stdio.h does nothing, so it does not need to be executed. So you what you want to do is, when you are writing a code, you want to use the functions that have been defined in stdio.h, and for that purpose you just include stdio.h or import the functions of stdio.h into your code. And your code, because it needs to run, it needs to be executed, it needs to have a main function. That is what I was trying to say.
Yes, sir.
Okay. Okay, I think there have been some few questions. Okay, in some examples, only main are used. Is it void main? Okay, yeah, the default is int in C, but if you go to other languages, you can there might be void main, but mostly wherever you want void, you want a function to be a void type, you have to explicitly mention that. And in C, if you write main, then it considers as int type, like the return type to be int for the function. So yeah, the answer is correct. I think, yeah, Rohit has given the answer, so that is correct. Okay, if there are no more doubts in this two questions, what is the maximum size of an array while initializing? Okay, so you can initialize an array as big as your memory available to you. That is, so every program is given like a memory. Like if you are running an IDE, then there is a memory allocated to the IDE. Yes, it is highly system dependent, depends on the processor, depends on the compiler, but like whether it's a 64-bit processor or a 32-bit processor or so on, so it will depend on all of that. But you can go till the maximum size that is allocated to your particular program. Okay, so that happens in the background, and you can initialize an array of that size. Yes.
So what is the size of integer data type?
That also varies from system to system. In some systems you have two bytes. In some systems you have 4 bytes. And I think in the recent systems you have int data type is of 4 bytes, and like float is of 4 bytes, double is of 8 bytes. I think that is how it goes. But yeah, for 64-bit systems, I think that is what it is. But yeah, it is dependent on the processor, basically.
Sir, if you work on Turbo C, it gives 2.
Yeah, because Turbo C is a older version of C. It's really outdated by this point, but some people do use Turbo C. But it more or less depends on the processor of your system. Like if it's a 32-bit processor, then I think it's 2 bytes for you. But at the same time, your compiler also plays a role. If you have a older compiler which was made to run the compiler was made to run on 32-bit systems, so it might allocate like 2 bytes for you for the integer for int. But more recent compilers will allocate, and on 64-bit systems you will have 4 bytes of memory for an integer.
So what if NPTEL asks this question? We should give 2 or
4,
4?
or basically, actually this kind of questions usually are not there, but and whenever they ask you to calculate something, for example in the first page I showed you a question where you calculate the memory location of the array, so that is a fairly common question that you get in the exams, and there they mention that.
Can you show me the question?
Yeah, sure. So this was the question on the right hand side. So this is basically, they mention that consider an integer to take 2 bytes of memory, or consider a float to take 4 bytes of memory. Like they usually mention that because it's very processor dependent, so they usually mention in the questions.
So that if they
Yeah,
didn't mention,
they usually do. That's how the questions come, like in NPTEL, as far as I know. But if they don't mention, then yeah, probably you should take 2 bytes and go ahead, because I mean I have not seen questions where they don't really mention it, so I cannot tell you that they don't mention it. But yeah, I mean they usually do. I don't think you will come across such a question where they don't really mention that, so you'll be fine.
sir, in 6th week assignment, it is a question like that.
There's a question. Okay, I'll look at it. So in 6th week assignment.
Oh yes, sir. They have mentioned that assume int takes 4 bytes.
Yeah, so they usually mention those kind of things. They don't leave that up to chance, because the questions are more or less, they are already, lots of questions are already set, and yeah.
Option B, sir.
The first one, yeah, that is correct, option B. Why? Because we have an array of size of 6 elements, 6 integer elements, and you are initializing it to this 6 values that you have, and you're doing a switch case, which is with size of a. So size of gives you the number of bytes occupied. Okay, number of bytes occupied by a. So you talked about a question where they don't mention it, so here they don't mention it, see. But here it doesn't matter as well, because they have given the question in such a way that whatever you take as the size of a single integer, you will get the same answer. So if I take, say, one integer is 2 bytes, okay, let me take that first, and I compute that. So size of a is how much? So it has six integers, so 12, right? And we don't have a case 12 here, so we just go outside the switch case and we print IIT Madras. Okay, now let's say I take an integer as 4 bytes, and what would be the size of a? It would be 24, right? So in that case as well, there is no matching case. We go outside the switch case and we print IIT Madras. So in both cases the answer will be the same. So in questions like this, you don't really need it to be mentioned that take an integer to be carrying 2 bytes or 4 bytes or whatever. You don't really need that to be mentioned, right? So
Okay, sir.
yeah. Okay, I think this was clear. So size of size of, let me tell you an important thing about size of. That size of is not a function, rather it's an operator. So it's classified as a special operator, which returns to you the memory space occupied by that variable in bytes. So it returns to you, okay, yeah, I have written that already. So it returns to you the number of bytes that is occupied by the variable, and it's a special operator. Okay, so let's go and see the next question. So this question is important in the sense that I have seen a lot of questions of this kind come in the exams, because it's related to how you are accessing the array, and how basically a little bit of pointers, which will be covered I think after 2 to 3 weeks, but it's more to do with the address, memory locations and memory addresses of the array that you are accessing, and how actually you are referencing a certain element of the array. Okay, so let's try to answer this.
Sir, option D.
Okay, we'll see. So you have an array of 10 elements, and you're fixing a few of the elements you are initializing. So let me write those elements down, or rather the indexes down, so that it's easier for me. Right, so basically you are initializing 8 elements, and their indices would be like this, and then you would have 0 and 0 right after this. So this would be index 8, and this would be index 9. So this would be your array, complete array. All right, now what are we trying to say is that ARR plus 1 referencing 5. So this is this square braces. So a or any variable, square braces, this is this is called the referencing operator. So I would call it the array referencing operator, because it's exclusively used on arrays. Now all right, so that basically how the compiler treats it. We'll see that. So when you say this ARR of 10, I told you in the beginning that array is a set of contiguous memory locations, and when you define an array, what you get back is the address of the first memory location. So somewhere in the memory you have all this 1 2 3 4 5 6 9 10 0 0. This is saved in somewhere in the memory, and you get the memory location of this. So ARR is basically this, or rather I would say the address of this. Okay, let me write ARR. I'll explain to you later why I wrote ARR here. So ARR is this, that means the address of this, and star ARR is 1. So basically I would say ARR is the let me think, how should I mention this? Okay, is basically the address of ARR of 0. Is that I think this is easier to understand. So when you say just ARR, that means, yeah, I don't want to use the word pointer. That is why I was going round and round, beating around the bushes. But because pointer is not something that will be covered for 2 more weeks, so yeah, I don't want to use the word pointers. Yes, so star ARR basically means that it is the value at that address, and just ARR means it's the address of the first of the first element of that array. Now when I say ARR plus 1, what happens then? That means it's the address of the second element of the array. Okay, so it's basically this when I say ARR plus 1. Okay, so now here when I write ARR plus 1, that means it is pointing, currently we are pointing to the first index, that is, earlier we are pointing to the 0th index, now we are pointing to the first index, that is the element 2. Okay, the address of the element 2. Alright, now what we do is we do a referencing operator with the value of 5. So in that case, what happens, this entire thing, value of 5, can be written as star of ARR of 1 in bracket plus 5, then I can just write ARR plus 6, right? Is that too small to see, or I mean I can rewrite it. Probably I should. Okay, so basically this can be written as star of ARR plus 1, I put another braces, plus 5, like this. Okay, then this I can again rewrite as equal to star of ARR plus 6. Alright, so basically what does that mean? So ARR means the first element, pointing to the first element. ARR plus 1 means pointing to the second element, that means the first index. And ARR plus 6 means pointing to the sixth element, that means the fifth index. And here what is the fifth index? You have 6, that is the fifth index, right? No, wait, sorry. So we were pointing to 0 or 0th index, and we add it up by 6. That means we are pointing to the 6th index now, that is 9. So your answer will be 9 here. So let me reiterate it again. So when I was just saying star of ARR, that means I was pointing at the 0th index, and when I said star ARR plus 1, that means I was pointing at the first index. Okay, that is the second element. Now when I am saying star ARR plus 6, that means I am pointing to the 7th element, that is the 6th index, that is value of 9. No, it does not get the value, because that is what the referencing operator does here. So this expression, writing it as this, is the same as writing it as this, ARR plus 1 plus 5. This is what we have basically written. So we can if you this is how the compiler takes it actually. So you have ARR plus 1, which is written here, plus 5. So basically this becomes ARR plus 6, which is what we are calculating, and ARR of 6 is 9. So 9 is what is going to be printed here. Is that kind of clear? Think yeah, if you have any doubts you can ask now.
So what if they give ARR minus 1?
Then you will get an error, because you are pointing to a memory location and you are trying to access a memory location which is not really available to you. So -1 memory location is not something that you can access. So yes, but if you are at the end of the array, like you have traversed the entire array and you have gone to the end of the array, and then you are doing -1, that means you are just coming to the element before it. So if I am at the first element, like at the 0th index, and I am doing ARR -1, so it will give you a error simply. Okay, but if you are at any other element of the array, doing a ARR -1 will give you the previous element.
So what if we give, instead of addition, we can give multiplication? How it behaves?
Multiplication? No, I'm not sure. I don't think you can actually do a multiplication on this, because it is the way addresses work. So how addresses work is that because this is a continuous memory location, it is a contiguous set of memory locations, then you can say if you write ARR plus 2, that means it will traverse you by 2 elements. Okay, but and that is what ARR plus 2 means. If you write ARR into 2, it does not make any sense, because it does not really work that way. There is the multiplication operator is not defined to work with addresses, basically, that I can say. Is that clear?
Okay, sir.
Yeah.
So will it throw error for that?
Yes, it will throw an error for that, because multiplication cannot be done with an address. Okay. Okay, so if there are no further doubts on this question, then I can move on to the next one. All right. Okay, so for the next question, we have an array of, it's quite straightforward. It's actually easier than the previous questions. I think you can answer this by your own and move on to the other question that we have.
Option B, sir.
Yeah, basically, yes. So what you are doing here is you have an array of size of 3 integers, which is 10, 12 and 14 initially, and the indexes are 0, 1 and 2. These are the indices or the index, and this is the value, right? And I'm accessing a of 1. I'm changing the value to 20, so instead of this, 20 will be saved now, and I'm putting it through a while loop and printing the value of every element of the array. So a of 0, a of 1, a of 2. Okay, and a of 0 is 10, a of 1 is 20. Now I have changed that. Now a of 2 is 14. So you have 10, 20 and 14. Okay, all right. Yes, so B is the correct answer, and so we can, I don't think this, does anyone have any queries regarding this, or we can go to the next question here?
Yes, sir.
Okay, so try to solve the next question. Here we have a array of 5 integers, and we do a lot of prefix and postfix increment operations. Do them carefully, and yeah, just try to solve this and get the answer. So for this question, let me write down the array. So we
So
have
option D.
option D. Okay, B.
B.
Okay, let's see what the answer should be. So this is the array basically, that is initially 1 2 3 4 5. I have initialized the array. Then I'm saying AR of, so the, let me write down the index as well. So this is 0 1 2 3 and 4. So these are the indices of the array, and these are the values initially. So what I say is ARR of 1 is equal to plus plus ARR of 1. That means the value of ARR of 1 increases by 1. So ARR of 1, that is the first index, is 2. So now it becomes 3. So this is the new array after the first statement. Then we do a is equal to ARR of 1 plus plus. All right, so it's a postfix increment operation. So a will get the value of ARR of 1, which is 3 here. So in this step, a becomes 3. But after that is done, like the assignment operation is done, you have the value of ARR of 1 increased by 1 again, so it becomes 4, right? So this is the new array, and the value of A is 3. Now the next statement what we do is ARR of 1 is equal to ARR of A plus plus. So A plus plus, again it's a postfix increment operation, right? And that means you are basically doing ARR of 3 here, and then you are increasing A to 4. That is what is happening here. So ARR of 3, ARR of 1 is equal to ARR of 3. So what is ARR of 3? The third index, which is the value of 4. So you are trying to save it here, right? And that basically results in the same array. There is no change in that array, but the value of A becomes 4 after this, right? And you print 4, you print A and ARR of 1, which is 4 and 4.
Yes, sir.
Yeah.
Sir, could you please explain it again?
Okay. So initially this was my array 1 2 3 4 5, and these are the indices 0 1 2 3 4. So the first statement I said is ARR of 1 is equal to plus plus ARR of 1. That means it's a prefix increment operation. So the value of ARR of 1 increases by 1, and it is saved in ARR of 1. So ARR of 1 initially was 2, it was incremented to 3 and saved in the same ARR of 1. So now the new array became this 1 3 3 4 5. So this is your after the first step. Now what we say is A is equal to ARR of 1 plus plus. So postfix increment. So A will have the value of ARR of 1 before it gets incremented. That means 3. So A will become 3, and ARR of 1 will be then incremented to 4 because added up by 1. It's a postfix increment operation. So it becomes 4. So now the array is 1 4 3 4 5. All right. Now the next step what we do is ARR of 1 is equal to ARR of A plus plus. So A plus plus is again postfix increment. So basically you are saying that you're doing ARR of 3 because A was 3 earlier, so that is what you're doing here. So ARR, what is ARR of 3? It is 4. So that value gets stored in ARR of 1, which is basically 4, so it doesn't make any difference actually. So your array currently is 1 4 3 4 5, and it's a postfix increment operation. So A becomes 4. A was 3 earlier, it becomes 4. Now when you print it, you have 4 and 4 getting printed. Is that clear?
Okay, sir.
Okay, so if this is cleared, then we go to the next question.
Yes, sir, clear.
Okay. Alright, so we have an array here which is basically 3 1 2 4, and we are saving the first element of the array into a variable called result, and then we are iterating over the other 3 elements of the array and doing some checking using the if condition, and we are printing the result finally. So yes, 4. Okay, so basically what does this program do? Like, what is this
Finding
program?
largest number.
Good. So this is to find the largest number of an array. So this code will calculate the largest number of the array. So what we do here is we set the value of a variable result to the first element, and we start checking it against the second element onwards. Okay. Now that is why our iterating counter starts from I is equal to 1, not 0, because the 0th element we have already stored in the result. Now we check 3 with 1, so we check the result with A of I, which is A of 1 initially. So what happens then in the first iteration? What do we check? So we check if result, which is 3, so let me write that down, result is equal to 3 because a of 0. So we check if 3 is greater than 1 because I is 1. So we check if 3 is greater than 1. Yes, it is greater than 1, this is true. So we continue, that means we skip this result equal to a of I, we just skip that statement, go to the next iteration. So we go to the next iteration and we check is 3 greater than a of 2, and what is a of 2? A of 2 is 0 1 2, right? It's 2, so it's still true. So again continue, go on to the next iteration. So what happens in the third iteration? Is 3 greater than a of 3? A of 3 is what? 4. So this is false, so continue will not be executed. So what happens is result is equal to a of 3, right? So what is a of 3? It is 4. Now after that the loop exits because I less than 4, so I becomes 4 after this. After the third iteration I becomes 4, so the loop exits here, and when we print the result we get 4 as the output. So this is a code for finding the largest number of an array. Okay, so if there is any doubt then you can just ask it now.
Sir, could you repeat, please?
Okay, so what this code does is first it sets the result value, the value of a variable result, to the first element of the array, and then we start a for loop iteration from the second element onwards. So first, in the first iteration it checks if result greater than a of I, that is a of 1 for the first iteration. So it checks 3 and 1. So this is, if you write the indices, it is like this, right? So now a of 1 is 1, so it checks is 3 greater than 1. Yes, it is. So continue statement is executed. It skips over the rest of the iteration and goes to the next iteration. So in the next iteration what happens, it checks is result greater than a of 2 because I becomes 2. So if a of 2 is 2, so 3 greater than 2 is true. In that case again continue on to the next iteration. In the third iteration it checks is 3 greater than a of 3, and a of 3 is 4, and 3 greater than 4, no, it's not greater than 4, so it's false. In that case continue is not executed, it goes to the next statement. The next statement is what? Result equal to a of I, that means a of 3 here, so a of 3 is 4, and after that the for loop exits because the I value becomes 4, and the condition here that we have mentioned is I less than 4, so the for loop will exit and it will print the value of the result as 4. Is that clear now?
Yes, sir.
Okay, so then we can move on to the next question. Alright, let's see. So we have a integer n equals 2 and a sum which is equal to 5, and we do a switch case of the integer variable n. So switch of 2, so we go to case 2, we see that sum is equal to sum minus 3. So what happens to sum is equal to 5 minus 3, sum becomes 2, but there is no break statement, so we go and execute case 3 as well. So what happens then? So 2 into 4, that becomes 8, and then we have a break, so it breaks out of the switch case statement and it prints sum which is 8. I think this is something from the previous
Yes.
previous week's lectures. So yeah, I hope this is clear.
So what if we don't give break for?
if you don't give break, then it will go and execute default as well, so sum will become 0, and here 0 will be printed instead if we don't give this break.
So, but the default statement also doesn't have the break statement.
Yeah, but that is the last statement, so it goes out after that. So after that the switch case block ends. So yeah.
So can you explain case 3 for me?
Case 3.
Yes.
Okay, so what happens here is after case 2 there is no break statement, so the program falls through, the flow of the execution falls through and it executes case number 3, and this basically means sum is equal to sum into 4. This is a shorthand notation of that. So this is the same as writing sum equal to sum into 4. So that is what we have done. So in case 2 what happened is we did sum is equal to sum minus 3, that is it became sum, the value of sum became 2, and then the case 3 was executed because there was no break statement after this sum is equal to sum minus 3. So the case 3 was also executed. This is what is called a fall through in switch case language, and we did sum is equal to, so we calculate sum is equal to sum into 4, which becomes, the value of sum becomes 8 because the value of sum was 2 into 4, 8, and then we have a break statement. We break out of the switch case and whatever the value of sum is printed, which is 8. Is it?
Done, sir.
Okay, if there is any further doubts here.
No, sir.
No? Okay. All right, so let's move on to the, okay, I have a question for you, like a C program. So write a C program to delete duplicate elements from an array of 50 integers. So you take an array of 50 integers, take the input from the user, and then you check all the duplicate elements. So let me first give you an idea of the algorithm, then I have the code in the next slide, which will just very briefly go through, and you can I'll share the PDF. When I share the PDF, you can just try working that out yourself. Okay, so say you have taken all the input from the user, you have saved it into the integer array of 50 elements using scanf and all that. So once you're done, so what do we do first? So what we will do, we have an array, we need to check the duplicate elements. So we will go to the first element, check all other elements with respect to it, whatever are the duplicate elements, delete those elements, shift the other elements up. Okay, and then we move on to the second element, check whatever elements after it, whether they are, and whatever whether they are duplicate or not. If there are any duplicate, delete that element, shift up. Then go to the third element, check with the rest of the elements if there is any duplicate of the third element. Then if there are, we delete those elements, shift up, then move to the fourth element, and so on. So that is how our program should proceed. So our first loop will be the outermost loop will be over the entire array, because we want to check all the duplicate elements, but it does not need to go to the end of the array, because the last we want to check is whether the second last element is a duplicate of the last element, sorry, whether the last element is a duplicate of the second last element. So that is what we need to check, the last one. So here I will take a variable which is size, because now our size is changing because we are deleting elements from between and shifting the rest of the elements. So the overall array that concerns us is actually smaller than it was earlier, because we deleted some duplicate elements in between. So the size will be variable, size of the array that we need is going to be variable. The array size is defined as 50, so it will stay as 50 throughout the code, but within that 50 there will be a certain elements which will have after we are done with the code, there will be only, the size will correspond to the number of elements which don't have any duplicates, which are all unique numbers. Okay, So the first loop here, I will have I'll start from the 0th element, but I'll go to size minus 1, because as I said, for the very last one, we need to check whether the last element is a duplicate of the second last element. So our outer loop needs to go only till the second last element. Okay, so this is my outermost loop. Okay, so inside the outermost loop, what do I need to do? I need to check, say I am at element some 10th element. I need to check from 11th element up till the whatever size is, and I need to check all of those elements and compare it to this element. If it is equal, then it's duplicate, right? So my second for loop will go from j is equal to I plus 1. That means from the next element of the ith element, say I am at I is equal to 9, that means the 10th element, I check from the 11th element onwards. So j is equal to I plus 1, j less than size, because here we need to consider the entire thing, the entire size of the array, then j plus plus. Alright, so this is my second for loop. Now inside this, what do I need to check? I need to check if they are equal. If all these elements, say I am at the 10th element and I checked 11th element onwards, so I need to check if 11th element onwards, if all of those elements, the values of those elements are equal to the 10th element. If that is so, if that is equal, then it's actually a duplicate element, right? So I need to do that checking. So then I write a if condition. Let's say I have the array variable is this, I mean ARR. So I write ARR of I equals ARR of j. Now if this is true, that means the jth element is the duplicate element, because ith element comes earlier, so I consider that it's a unique element. So whatever comes if whatever element comes after I, if the value are the same, then those are the duplicate elements. That's an assumption that I took. So the jth, if this condition is satisfied, ARR of I becomes equal to ARR of j. That means this jth element, whatever it is, I mean jth index element, whatever it is, that is the duplicate element. I need to remove that element. So now I'll remove that element, but what will happen after that? I need to shift all the elements one step upwards, right? I need to shift the elements one step upwards. So what I do is I need another for loop which will shift all the rest of the elements one step or one element up, that one element prior. Okay, so I write another for loop which is k is equal to, from where I need it from j, right? Because the jth element is found to be the duplicate one, so I remove the jth element. So I need to do it from up till j and up till size, because I need to shift everything from the till the size of the array, right? So and k plus plus. Now inside this, what I do is I have to delete the jth indexed element, so I replace it by the next element, or rather let me write size minus 1 here, because yeah, size minus 1, because of the way I'll be writing. Just hold on a moment. So ARR of k will be equal to ARR of k plus 1. Okay, so if this is the case, then at only we don't need to go till the end, because we need to go till the end minus 1, that means the second last, so that the last element of the array gets copied to the second last element. Okay, so that is why I wrote size minus 1 here instead of size. Okay, so we go from, so we do ARR of k equal to ARR of k plus 1. So in this, basically what we do, we shift all the elements one step up. Okay, and we delete the jth element. The jth element don't exist anymore. So this is what we have done. And once this is done, what do we need to do next? So here I can tell you two different methods of doing this. Now your size of the array has actually decreased by 1. So yeah, so we need to do size minus minus, right? Because the size of the array has now decreased. I mean, the size of the array is still 50 integers, but the size of the non-duplicate region, or the size that concerns us, which are containing the unique elements, are supposed to contain the unique elements, will decrease by 1. Okay, because we just removed a duplicate element from the array. Alright, then the other thing is, if we just end this loop like this, whenever there is a duplicate element and that duplicate element gets removed, what will happen is the j will still get added up. But you see that we found that this jth element was a duplicate element, and we removed this element and we shifted up all the other elements. But if we do j plus 1 or j plus plus, then it will go to the next element. So this element which moved up here, the element which are down here which moved up here, that will never be checked for duplicity. I hope you understand. So we had this entire array, and say this jth element or jth indexed element was found out to be duplicate. Okay, so what we did, we put this here, which is j plus 1, and now if we do here j plus plus, then we were looking at this element, but this element went here, and in the same array, now this, let me just shade it like this. So this element is now here, which is the jth position. If we do j plus plus, then we will be looking here, right? Our program will be looking here. So basically this element was never checked for duplicity. This shaded element that I am showing here, this element we did not check it for duplicity. So we need to do a j minus minus here, okay, because that will counteract j plus plus. Or we can do something even more elegant, that we just write the for loop like this, right? We don't do any increment there, we don't do any decrement here, we end this if just like that, and only in case of else j plus plus. So if there is no duplicate element, only then we will increment j. If there is a duplicate element, we'll still look at that same index, because now that same index contains a different value, because all the values were shifted upwards. So the same index actually contains a different value now, so we don't need to increment j in that case. Okay, only when there is no duplicate element that was found, then we move j to the next one. So basically this is how this code will go, right? So we have two curly braces ending here, and this is the algorithm. So is that clear, or is there any doubts or something of that sort?
So why are we putting size -1 in the I loop?
Okay, so okay, in the I loop, okay, because see at the when you have, say, consider a case where you have 50 integers here, right? So consider a case where everything above 48 was like, you have 50 elements, and up till the 48th element there was no duplicate cases. Okay, no duplicates. So I am taking the easiest one. So up till 48 everything was unique, so there was no duplicity. Now I see that 49 and 50 are duplicates of each other. I mean, 50 is a duplicate of 49. So this ith, that is the outermost loop, so ith loop basically refers to, it points to the one which is being checked across the rest that are coming after it, right? Do you understand that part? Like ARR of I, that the ith loop that I have used is for this particular element, which will be checked against all the elements that will come after it. So any element which comes after it in the jth loop is actually, if it is found to be equal, then it is a duplicate of the ith element or the ith index. That is the purpose of the I for loop that is we have here. So for this case, if we need to be at the second last element, checking against the last element, right? If we are at the last element, we don't really have any elements after that to check with. Okay, so if if we reach the last element, that means there is that element is not duplicate, that is a unique element. So we don't need to go till size, or we don't need to go till the last index. We can actually go till the index just before that and check it against the last index for duplicity. Do you get that? Yes.
Size is 50. If we give size minus 1, then it would be 49. So
Mhm.
it checks up to 48, I less than
Yes.
49. So it checks up to 48.
Yes.
The last value of I would be 48.
Yes. So basically
And
the
48 and 49 will be checking.
yes.
If we don't give size minus 1, it will be checking 49 and 50.
Yeah,
There will
and
be no 50.
there is no
That's why
50.
you have,
Yes, there is no 50, right?
that's why you
So,
have given size minus 1.
yeah, and we don't need to really check it with 50. By the time we reach that 48th element, if we reach the 48th element, that means everything is unique by then. I mean, till 49th element, if we have reached till 49th element, everything is unique. So whatever we have, everything is unique. There are no further duplicates because there are no further values after that, right? So you get the point, right?
Yes, sir.
Okay. So
Wait,
yes,
one more question, sir.
yes.
Why are we giving third loop, sir? I mean K loop.
Okay, the K loop is say you found that you started somewhere here. So you have I 1 2 3 4, I 0 1 2. No, let me not write I. I am just saying the index here. So you found out that this jth uh, indexed value is a duplicate value, and the program says delete the duplicate elements. That means I have to I have to just remove the duplicate element from the array. So what I will do is I will do something like this: j plus 2, j plus 3. So this will come here, this will come here. So I am shifting, I will shift all the values after the duplicate values one step upwards, because the duplicate value is now, I want to remove that, it doesn't need to be present. So I need to that is why I need this for loop, because I need to traverse across the remaining elements and shift them one step upwards. Okay, and
Yes, sir.
that is why I have
And
used the
here also we have given size minus 1.
yes, because you say k plus 1, what does that do? Like, you are referring to array of k plus 1, right? So if you are at 48, you refer to 49, but if you are 49, then you refer to 50, which is not there actually, it doesn't exist, right? So
Yes, sir.
so the same kind of concept. It's k plus 1 will be 50. If k is 49, then k plus 1 will become 50, and 50 is ARR of 50 is actually not valid, it's an invalid memory address.
Sir, but so K will not become 49 because of size minus 1.
Yes, it will be at 48, so that the 49th element value gets copied to 48
Okay, sir.
in that case.
Understood, sir.
Yeah. Okay.
Sir, I have a one question.
Yes.
How I can get this PDF?
Okay. Yeah, I can give you the link to that. Give me a minute. So I have posted a link in the chat box, so you can follow this link for all the videos and the PDFs and everything that um, all the three TAs cover in the in their respective classes. So all the recorded videos and the PDFs of this material, everything will be available through this spreadsheet link that I just shared with you on the chat. Okay.
Sir, I have another question.
Yes.
We are reducing the size after we remove the duplicate.
Yes.
Sir, does it really decrease the size, or
Yes, it does. We need to remove it after we remove the duplicate, right? Because yes, we need to do that because uh, before before we are how are we removing the duplicate? We are removing the duplicate by copying the next element to the previous one, basically shifting all the elements upwards. But the element which is at the size size minus 1 index, that is actually not a duplicate element, or we don't know, we have not checked that to be a duplicate element. So that needs to be shifted first, and then size needs to be deducted, so that we consider that now the size is like lesser, right?
So my question is, here we are reducing the size
Mm-hmm.
to print the values after removing the duplicate.
Yes, we are
But the elements will not be deleted, am I right, sir?
yes, the elements are not going to be deleted, but uh, basically this size will have the number of elements which are unique. Finally, after your code ends, like this entire algorithm functions and it's the entire computation is over, so size will be 0 to size minus 1 will be the number of elements which are unique in the array. So the array will
So the allocated memory will be same after even
yes, yes,
deleted the
yes, exactly. So here the allocated memory will still be 50 integers, okay, but
okay, sir.
just that among those 50 integers, the first size number of integers are unique. So that's what we are doing here.
Sir, I have one
And
question. Can also we can gain a size of minus previous size, and after deleting duplicate size we can minus both and we can get the size of the
uh, like yeah, the previous size is 50, if and after this entire thing gets over, so you can find the number of duplicate elements of the array in by doing that. Yes, so the final size minus the initial size, sorry, the initial size minus the final size will give you the number of duplicate elements in the array. Yeah.
So another question.
Yes.
So we are giving J++ here.
Mm-hmm.
You have told that we can give J++ and here we can give J minus minus.
Yes, if we
Why
give
should we giving
yeah,
like this?
yeah, this is a more elegant way of doing things, because what is the point of doing a plus plus and doing a minus minus and then again a plus plus? Why to do extra computations, right? So instead we can just give a case where the increment of j occurs, right? Like that is the point, because if I give a j plus plus, I have to give a j minus minus after the size minus minus, I have to give a j minus minus,
Yes, sir.
but it's the same thing.
Why should we give J minus minus, sir? That's my
Okay,
question.
okay, why should we give j minus minus? Okay, so see this diagram that I drew. So I had the jth indexed element, which was the duplicate element. Okay, now I shifted all the elements after it, and some new element, that is the shaded element, now is at the jth index. You get this, right? So after I shift all these
Yes, sir.
elements, the scale loop is done. So in that case, what happens is, if I move to j plus 1, that means I do a j plus plus in the for loop itself, without doing a j minus minus. So I go actually to the next element, I check this element, this one, not the shaded element. The shaded element is now at j, and I am checking at j plus 1. So the shaded element is not checked for duplicity, that means.
So I still don't understand.
Okay, okay, so let me explain it in this way. So say you were checking against the 10th element. Okay, so your I was 10. All right, so basically the 11th element, but I'll say index. Now I am talking in indices only. So I equal to 10, this was the element that was being checked against, and say j equal to 20. So I had this element which I was checking against this I, and that was the 21st element or the 20th index element, and that I found to be duplicate. And say this number was 53, and say 20, let me just draw it like this: 20, 21, 22, 19. Okay, fine. So now what I am saying is this j, I found out this is 53, this is 61, 63, and so on. Okay, whatever numbers, I am just taking random numbers. So so 53, now this is a duplicate, that means this 20th element is a duplicate, right? So I need to remove this. So what I am doing, I am doing all this copying procedure, and then I get something like this: 19, 20, 21, 22. So now my 20th element is 61, my 22nd element is 63,
63.
right? Now consider this case, j was 20. Okay, now if I don't do a j minus minus, I just have j plus plus here in the for loop. So after this iteration is over, this particular iteration is done, this copying is done, everything is done, size becomes minus 1, size is equal to size minus 1. After that, what happens? J plus plus happens. So j plus plus means I will point now at 21, I mean 21st element, 21st element. So 21st element is actually 63. So we actually missed 61, we didn't, because we copied 61 to the previous element, right? And we are, and as a result, we forgot to check it against 61. You understand?
Yes, sir.
So that is why
Understood,
this j minus minus needs to be there if you are writing a j plus plus inside the for loop. Else you can write it in this way, that as long as I am finding a duplicate element, I won't increment the value of j. If there is no duplicate element, then only it will go to j plus plus. So
So the point is there may be another 61 in the previous.
yes, the point is here it might be 53 again here. We don't know because we shifted it up, but we didn't check it against it. So this 61, it might not be 61, it might be 53. Who knows, right?
Yes, sir. Yes, sir.
Yeah.
Thank you so much.
Okay. Yeah, it's good. Yeah. So I hope it's clear to everyone. So this is the code that I had for this. So as you can see, it has been done in a similar manner. Actually, this should be size minus 1 here as well, but yeah, you can do that by yourself. Okay. This is size minus 1 as well. Yeah, the minus ones are all missing. When I upload the PDF, I'll probably modify this, or not. You can do this by yourself, or I can just modify it here. So instead of writing size, I write size minus 1. Similarly, instead of writing size, I write size minus 1. I think these are the two mistakes here. Yeah, that should be fine. I think the rest are the same. Alright, so is there any other doubt regarding whatever was covered in this class? If not, then I'll be ending the class here. So the next class actually will be on Friday, this Friday, that is 10th of March, the same time, 7 to 9, instead of the next week's Tuesday. So the next week's Tuesday class has been preponed to Friday 7 to 9, and there will be no tutorial session from at least from my side for the next week. Okay. All right, so see you on Friday, 7 to 9. Thank you for joining.
Okay, sir. Thank you.